All right, it is 12:02, so I think we can go ahead and get started. Good morning and afternoon, everybody. My name is Stephanie McCowett. I'm the marketing manager here at DATAMARK, and I just wanted to say welcome to our first webinar of 2024, GIS Data Remediation for Next Generation 911. I'm so excited to be joined today by John Green, who is our business development manager at DataMark, and Adam Todd, who works on our project management office. So welcome. A few housekeeping items before we go ahead and get started here. Everybody is muted for quality assurance purposes. If you want to communicate with the hosts and panelists, go ahead and use the chat and Q&A section of the webinar. There will be plenty of opportunity during this webinar to interact with everybody, and we always check the chat. So make sure that you're using that and checking it to see kind of what the conversation is in there. This webinar is being recorded. We will go ahead and put it up on our YouTube channel after the recording is finished, and we will send out an email to all registered attendees once that's ready, so you guys don't have to worry about checking up on our YouTube channel whenever that's ready. I think that without further ado, that's really it on my end. Adam and John, you want to go ahead and take it away?
All right, thanks, Steph. And again, welcome everybody to our first 2024 webinar series. So we'll start with some introductions. I know Stephanie kind of gave you a brief introduction, but Adam, if you want to go ahead and tell us just a little bit about yourself.
Yeah, so good morning and afternoon, everybody. Thank you for taking the time to be with us today. I'm excited to be doing my second webinar here in my second year now with DataMark. So very excited to kick this year off and get to spend some time with you guys today and discuss some important topics. I've been a GIS analyst with us, like I said, for about 2 years now, working on various projects and things like that. So again, excited to be here, and thank you for taking the time to hang out with us today.
Thanks, Adam. And again, my name is John Green. I am one of the business development managers here at DataMark. I've been here, I think this is going on my fifth year here at DataMark. So I live in Eastern Tennessee. The accent may give it away for some of you guys already, but a very eastern corner of Eastern Tennessee. I'm almost in Virginia, and I'm almost in North Carolina. A little place called Jonesboro, Tennessee. I've got 3 kids, all of them are grown, and I just had my 3rd grandchild, so I'm showing my age a little bit, I guess. I've been doing public safety GIS now for, going on, I think I started in '96, so close to 25 years. Had some other disciplines involved in that career over the years. I did a little bit of utility work, done some surveying, worked as a surveyor for a little while. But the majority of my career has been, my passion anyway, is using public safety GIS to help save lives and protect property. So that's a little bit about me. Just looking at the agenda today, we're gonna look at really what is GIS data remediation, and why should you even worry about it? Why should we be doing GIS data remediation? And then I'm sure you guys have probably heard about the 98% match rule, so we're going to dive into that a little bit more. We're going to look at, do you really know if your GIS data is ready for next generation 911, and how can you know that? Then some of the data requirements for next gen. And Adam's going to tell us a little bit about the tools and technology that can help prepare us for that. And then look at some of the key examples of that technology. And then towards the very end of the presentation there, we're going to have some funding examples too that can help fund some of these projects. So that in a nutshell is what we're going to talk about today. And I think what we'll do is we'll start out with the why behind remediating your data. So you have to ask yourself the question, why should I bother remediating my GIS data? Well, GIS is really transforming the way that we look at the world nowadays. I mean, take your cell phone, for instance. You have a GIS right here in the palm of your hand through Google Maps. Whenever you look at technology today, we just about do everything we do has some form of map component to it, whether it's ordering food, whether it's placing an Amazon order, finding directions around town. So, we're using GIS in new and inventive ways now. And one of those ways is how that we handle 911 calls. And how, excuse me. And so to really understand that, you kind of have to understand how that we've handled 911 calls in the past. And so, routing 911 calls is in our legacy systems has involved tabular databases such as your MSAG and your ALI database, and even selected routers. GIS wasn't really fully utilized until the call was delivered to the dispatch center. Well, with Next Generation 911, we're putting that GIS technology on the forefront of that call routing process. And so to be able to use GIS to route your 911 calls with, you really have to have your GIS tell the same story as those tabular databases did at a bare minimum. And that's part of GIS data remediation. Another good reason that you should remediate your data is whenever you start thinking about calls, misrouted calls and call transfers. So let's say that you happen to be on the county border, and you near a county border, and you dial 911, and your 911 call happens to bounce off a tower in the neighboring county. Well, then your call will be routed to the wrong public safety answering point or dispatch center. Well, they can transfer that call back over to the right dispatch center, but you're losing time there. You're losing precious time in that call transfer. And there's still many places in America today, whenever you do that call transfer, you lose your location information whenever you do that call transfer. So you're back to square one and trying to be able to find that 911 caller. Now, the difference there with using GIS is we're able to reduce we're finding the location of that 911 caller before the call is routed to the PSAP. And so we're able to reduce the amount of call transfers that happen because you're bouncing off the wrong tower. Is it going to completely eliminate call transfers? Absolutely not. You're still going to have them. It's still going to be an issue, but you can definitely drastically reduce the amount of call transfers that you do. And then speaking of call transfers, if you have your GIS data to the right states, meeting the right standards, and you're using it to route 911 calls with, you can do cross-jurisdictional call transfers. So let's say you do need to route that call across a jurisdictional boundary. Not only can you route that call, but you can also carry all of the location information and everything that came with that call. You can carry that along with the voice, and you're not back to square one and trying to identify the location of that caller. Whenever you start thinking about how addresses are validated nowadays, your traditional validation, you're using a master street address guide or an MSAG. And so you apply for a new service, you turn your 911 address into, say, your service provider, and it's validated against a road range and a street name. Well, the problem there is you're comparing against a range of addresses. So it's a one-to-many comparison, and it's I won't say prone to error, but you can definitely introduce some errors there. So with GIS data, you're able to take that down to a finite validation process. You can do a one-to-one comparison on your data. You can compare your new address against map data and see if that address is valid. And then another good reason that you should remediate your data, at some point you'll need to match your GIS data to your neighbor's GIS data. So when you start thinking about state deployments or even regional deployments, at some point you're going to have to bring the boundaries together. You can't have any gaps or overlaps in the boundaries, but it really goes even further than that. So you're not only comparing the boundaries, but comparing how well your road center lines match up at the endpoints there at the boundary. Are they snapped together? Do they miss each other? Do they overlap? And then your address points. Do any of those address points along the border, do those fall in any gaps or overlaps with your boundaries? And then another good reason that you should remediate your data is just it's going to become more accurate and more reliable. And that's not to say that your data is inaccurate today. Your data is going to be used for a whole brand new purpose and compared against a whole different set of standards. And so you want to make sure that data is as accurate and reliable as possible. And so I could go on for the rest of the presentation here and give you all kinds of good technical reasons why you should remediate your data, but I want to give you the best reason of all. So this is the best reason of all. This is baby Kaya. This is my 2-month-old granddaughter. And if she's in trouble, if someone's breaking in the house, if there's a fire, if there's a car wreck, if she's choking, I don't want to be fumbling around with trying to find where she's at. I don't want to be trying to validate her address at that point. I want the cops there. I want the ambulance there. I want the fire truck there as quickly as possible. Because if you're waiting to figure out those problems and the call's already happened, you've waited too late. So throughout this whole presentation, I want you to keep that in mind. That the biggest reason you should remediate your data is because there's lives hanging off the end of it. You know, the address that you correct, the ESN number that you confirm, the overlapping road range that you take care of, all those validations, all that correction could save someone's life. And I mean, if you spend $1 million in correcting your data and it saves one life, it's money well spent. So that's the biggest reason for me, and that's my cuteness for today there. I want to hear from you guys too. So I saw a question or two come in on the chat. What are your thoughts on other reasons why you should remediate data?
And I see too, we do have a question from Vicky asking, is the current MSAG database the backup if next-gen 911 routing fails? So that's something that we'll definitely talk about, at least in the data requirements piece. And John, I know you touched on it, and you'll touch on it some more. It's definitely something that we consider when you see us talking about legacy data. That's something that's going to be extremely important to keep up with, and as a requirement of these standards to have that synchronization. So yes, the short answer to that one, and I'll let you elaborate, John, if you'd like.
Sure. So there's a lot of folks term this as the legacy gateway in a next-gen system. And true, if spatial routing fails, you're still gonna have to know how to route the call. So a form of the MSAG will kind of serve as your backup. And then as folks transition from legacy to next generation 911, you know, it's not a switch that you flip that all of a sudden you're next gen compliant. It's a gradual process in most cases. And so at bare minimum, you maintain that legacy as you're transitioning over to next generation 911. But I know here in my home state of Tennessee, they call it an MSAG. It's generated off of your road center lines, and it's managed in a similar way the MSAG database is managed, but it's there for that legacy call routing. It's a great question. Please keep those coming. The more questions you guys ask, the easier our job is today. So, all right. So some of the benefits of next generation 911 GIS. I mentioned this earlier, but we're getting the caller's location with the call. Now that's completely different than the way that legacy systems happen. So with the legacy system, you don't have any type of geospatial information until that call is already at the dispatch center. And then once it's at the dispatch center, you know, your call handling equipment, your mapped alley will use the alley information in the call to actually map that call. Well, the difference with next generation 911 is we're locating that caller as a first step. And then depending on where that location is, we're routing the call based on location. So that in turn means that you have more accurate locations overall, because you're sort of forced to you're sort of forced to look at those locations ahead of time. And then it's much easier to locate and resolve data issues. You know, just looking at a flat tabular database, a lot of times it's hard to identify errors. And then with geospatial call routing, it's much more flexible. For instance, you can do temporary routing polygons. A good example here locally, I don't know if we have any NASCAR fans on the line here. I'm not a NASCAR fan, but we have a local racetrack here in Bristol, Tennessee. It's called the Bristol Motor Speedway. And whenever a large race happens, the city of Bristol opens up a command post there next to the racetrack. And they have a specific polygon that goes around the racetrack, and all 911 calls are routed to that command post during the race. Then after the race is over, they remove the polygon. Routing goes back to the way it was before the race. So it's more flexible, it's more automated. We talked about call transfers before, so you get more accurate call transfers. And then ultimately that reduces response times and hopefully helps save lives. Now, some of the other benefits that you may not really be thinking about is how it affects our legacy solutions. So because we're remediating this data and we're getting more accurate locations, more accurate, reliable data, that in turn bleeds over into solutions like CAD and Mapped Alley. And then, believe it or not, that can even have an implication on some of your RMS systems as well, your records management systems. So think about the call process whenever it hits the PSAP. First it comes in on call handling, it gets mapped through Mapped Alley. That location, address, sometimes even the XY comes into a CAD system. And then if there's a incident number generated out of that CAD system, a lot of times that incident number will end up over in an RMS system. And that RMS system will pull the address information over with it as well. So later on, whenever you're doing things like crime analytics, you're able to improve the way that you're doing those crime analysis, based on the GIS data that you improve way up the chain. Another thing that folks don't think about is like vehicle routing. So a lot of your CAD systems nowadays are using linear routable networks to determine unit recommendations. And so if you're remediating your data and you're getting that data down to a fine art, that's going to improve how well you can utilize that data in something like unit recommendations. And so instead of just going through a vehicle rotation or a unit rotation, you're actually able to use things like speed limits and one-way streets and other impedance values to interact with an AVL system to figure out where the closest unit is based on all of those different impedance values. And then lastly, think about the other systems that your address and road information can show up in. Public records, utilities, you name it. That more accurate address and GIS information will eventually bleed over into other systems outside of public safety as well. All right, so I used to have this boss, and his favorite saying was "So what?" And he never meant it in a mean way, and I don't mean it in a mean way here today. But I think we've all heard of this 98% match rate, and with that, I'll say 98%. So what? 98% of what? And so let me take you back to the time, and again, I'm going to show my age here, but it's a time that we didn't really have cell phones. And so, when I first started in this industry, less than 25% of all cell phones were capable of showing you their location in a 911 call. And then by 2005, about 95% of those phones were capable. But, even as late as 2010, there still wasn't a terrible amount of cell phone calls. So what you were able to do, what that meant is every address, just about every address, had a landline telephone tied to it. And that landline telephone had a service address. And so you could take that tabular database from the telephone company, compare it to your address point file, and if you could find 98% of those telephone lines in your address point file, that meant that your map data was complete. That meant that you found 98% of your addresses because everybody had a landline. Nowadays, Over 80%, sometimes 90, 95% of all 911 calls are wireless. And you can't really rely on that 98% anymore. So we have to come up with new and innovative ways to validate. All the blue that you see here on the screen would be folks that don't have landline telephones. That's about 20% of those dots that are green. So we have to come up with new and innovative ways to be able to validate those addresses that don't have landline phones now. And there's different comparisons that we run, different validations that we run. You know, we look for, we have this process called an ACE process, where we do an address comparison and evaluation. And it uses a host of different data sources to come up with address candidates, and then we look for those address candidates using other resource data. So that's, to me, that's really why you can no longer rely on that 98%.
We have a couple more questions coming in. One point from Rebecca, I think, is great. GIS also needs to make sure that they communicate with communication centers, administration, to make sure that they have the fields they need in order to make the data work in CAD systems. 100% agree. It's something that, as we talk about workflow, anytime that we mention workflow, it should be a part of that, to have that communication in there, especially when you're first establishing these systems. There's particularly a project that I'm working on right now with one of our clients, where it's absolutely 100% pivotal in making those connections with the spatial data and understanding what fields are required to meet both of those tasks, and get you to that, not only that synchronization, but ready for next gen 911. Tony asks, can the next gen 911 addressing consume a composite address locator consisting of parcels, points, and street center lines, or does it only consume networked streets and address points as feature data sets? So I can take this one, John, if you want. So for this one, you're mainly with the NENA standards, and we'll talk about this with the NENA data model, going to look at a layer of address points and a layer of street center lines. Of course, there's flexibility in adapting to the data that you have and those workflows, and they're going to be unique to each scenario. But I think that's generally what the standards point towards, at least when starting out and looking at next gen 911. Would you agree there, John?
Absolutely, and it's not to discount parcels or anything. The reason that we don't use parcels is, well, there's a couple reasons that we don't use parcels. You know, parcels, a single parcel of land can have multiple 911 addresses on it, so it's hard to nail down a situs address for each individual building on a parcel of land, each addressable structure on a parcel of land, or each dispatchable location on a parcel of land. So that's really the main reason. And then, you know, the situs address in a parcel database is typically not as important as the billing address. And so the billing address is often maintained a little bit more stringently than the situs address is. And so, you know, you could have a billing address that's across the county, across the country, and not even be associated with the actual 911 address there. Now, that's not to say all parcel databases are like that, but, you know, sometimes that situs address in a parcel layer is a little suspect, and then it's hard to make that one-to-many connection between, you know, if you do have multiple buildings on a single parcel of land. Good questions, though, guys. Keep these coming. These are great. All right, so where do I begin? My recommendation, if you haven't started remediation yet, and it sounds like most people on the call here are fairly familiar with the standards already, but I would encourage you to download a copy of the NENA data model and read it through. It's going to put you to sleep. It's a long document, and it's about as exciting as a technical document can get. You'll notice that the first, I forget what page number the requirements start on, but you'll notice very quickly there's a section that's the real meat and potatoes of that document. That's really what you need to focus on. I mean, read the whole thing, but make sure that you understand the technical requirements of that document. The other thing I'd recommend is get involved with work groups for NENA, developing these standards. They're happy to take more people. They're all the time looking for people to participate, and that's a great way to get it directly from the horse's mouth and see what's coming down the pipe. And then another thing too, reach out to us. We've got a multitude of folks on staff that are participating in those groups. And we usually have a pretty good insight on what's changing in the data model, what's changing in technology. And it doesn't cost you a dime to pick up the phone and call us and ask a question. So feel free to do that at any time. The next thing I would do is I would start collecting the required data. And so and you guys are probably familiar with this already, but the required data layers are address points, road center lines, your PSAP boundary, your provisioning boundary, and then your fire, medical, and law boundaries. And what we find predominantly across a lot of the projects that we work on is not everyone has all those layers. So you may not have a PSAP layer. Well, if you only have one PSAP in your county, chances are that your county boundary would serve as your PSAP boundary. And then if you have different municipalities, then your municipal layers may serve as your PSAP boundaries as well. Now, that's not to say that you take those as gospel right off the bat. You need to research them, make sure they're accurate, make sure that it actually does go out to the county border, so on and so forth. One other thing that we run into with boundary layers is folks may not have a fire, medical, and law boundary. If you have an emergency service zone boundary, you can start with that and start dissolving those based on fire, medical, and law response. And that's at least a starting point for your fire, medical, and law boundaries. The next thing that you need to do is consider your schema. So to me, you kind of have two choices with schema. You can either alter your schema to match the NENA standards, and that's a lot of work. There's a lot of pitfalls in doing that. I know that the GIS folks on the call here, if you've ever set up a county website, you change one field name, sometimes it can break the entire website. My home state here in Tennessee, about it's been almost 14 years ago now, they decided to enforce a standard schema across the state. And it worked great for NextGen. It broke a lot of things, though, and there was much wailing and gnashing of teeth at the local level. So I'm not saying it's the wrong decision. I'm just saying be careful of that whenever you're going in and looking at your schema. Try not to break your schema for any reason. The other option would be to use an extract, transform, and load tool, and that's exactly what we do here at DATAMARK. In fact, whenever you load data into our solutions and our VEP solution, the very first thing that you do is a field mapping process, and you save that field mapping. And then the next time that you load data into VEP, it takes your schema, translates it into the NENA schema, and you're off to the races. You can begin the next step, which is analyzing and comparing. And so we talked about the legacy comparison with MSAG and ALI. That still needs to take place. You still need to maintain that. But there's a ton of different other analytics that you need to go through. And we don't have time to go through each and every one of those today, but some examples would be, do I have overlapping road ranges? Do I have duplicate address points? Do I have odds and evens on the same side of the street? What's my parity like? And so you run that analysis, and then the real work begins. The remediation is really where the rubber meets the road. And what you'll find is the very first time that you run a remediation, it's going to find all the dust in the corners, and you're going to spend a lot of time looking at whether or not that anomaly. We call them anomalies for a reason too, by the way. We don't call them errors because sometimes that's just the way it is out in the real world. If you drive down Main Street here in my hometown of Jonesboro, the courthouse is on the wrong side of the street and it's out of sequence. It was also built in the late 1700s, and you're never going to change that address. They will meet you at the courthouse steps with torches and pitchforks if you try to change that address. So you have to go through and mark off your anomalies, and then what you'll find as you work through the remediation process is that remediation task gets smaller and smaller. It never goes away, And this is not a one-time thing. This is something that you're going to take on and you're going to repeat over and over and over again. But eventually you get into a maintenance mode to where you're only remediating a small portion of your data, but you're always running that analysis to make sure that data is good before it goes into the next generation system. So wash, rinse, repeat. It's a living, breathing animal, and it's something that never stops. Okay, I'll share another personal story here with you guys, and this is Scott County, Virginia. So I had the privilege and the honor of developing their data from the ground up. So in the late 90s, early 2000s, Scott County did not have any. They were at basic 911 and on a rural route and box system. And when I say we built the data from the ground up, we flew the county, we gathered planimetric data off the aerials. We used that to create road center lines and address points. We developed their ESN layers. We scheduled meetings with their fire, medical, and law to analyze those ESN layers. Assigned all the addresses, arranged all the roads, did all the field data collection. There's a ton of work there. So it's a couple years project. And this was my baby. This was my pet project. This is the one that, and I say I developed it. I didn't develop it. We developed it. I just happened to have the privilege of leading the team. Now, I did have the chance to maintain that data myself for a number of years after it was developed. And while the postal conversion was happening and the telephone conversion was happening, I had to maintain that data, and I had to maintain addressing. And at some point, we decided that before we actually go live with this data, we really need to run it through some type of validation tool. And I'll tell you what, I had to check my ego at the door, because I found all kinds of stuff. To my best efforts as a GIS person, as a GIS professional, to my best efforts, I still had a ton of errors. I still had a ton of stuff to fix. So, that's one thing I'll encourage you with the first time that you run your data through something like that. Don't be surprised. Don't take offense to it. It was eye-opening to me at the things that a comparison really found. And so what I found out was the stare and compare method just did not work. We had to have a set of tools to do it with. And this is even on top of a strategic maintenance plan. So we had a process that you had to take a single form and you had to go around to different departments, and those different departments had to put different information on the form, and then they had the circle stamp. Each one of them had their own circle stamp, and you could not get your lights turned on. You could not have your final building inspection completed. You could not get your water utilities turned on, your phone service, any of that, until you had that form complete and you took it to each department, and it had to be all filled out with all the circle stamps on it. So we had a very good system of assigning addresses and maintaining data, and stuff still slipped through the cracks. So I had to make a decision, and I thought, I'm just going to develop my own tools. We're on a county budget here. I'll develop my own tools. And I did, and they worked great until the first new version of ESRI come out with different DLLs and different programming and a different programming language. And then I had to recreate all my tools. And then that happened several times. And then, we started looking at next gen standards, and the standards were changing. So I had to go back and change my tools again. And so I ended up using a custom off the shelf set of tools. And that really worked for me, because now I no longer had to worry about those standards. I no longer had to worry about the technology change, and I put all that off on the vendor, and it just ensured that everything stayed functional. And as a testament to that, yesterday, whenever I called the current director there and asked for permission to use this slide, they're still using that circle stamp system. They're still keeping up with their data. They've got different tools now because technology is advanced, but they actually became one of the poster childs, if you will, for the state of Virginia whenever the entire state started going towards next generation 911. And the reason they were able to do that is because they made it important. they said, okay, this is very important data. We need to maintain this data. We need to have processes and procedures in place. We need to have the right tools, and it has to, again, this is going to save someone's life. We need to put an emphasis on all of this this maintenance that goes into it. So that's how you have to validate your data. Don't just assume that. Use me as an example. I couldn't assume that just because I developed the data that it was ready for prime time. Make sure you run it through some type of comparison, some type of validation, at least to get that sense of mind that your data is ready. All right, with that, I'm going to take a break and let Adam talk for just a moment here about some different technologies and workflows. And Adam, without further ado, I'll let you take it away, sir. I'll watch the comments in the chat here.
All righty, and I know that we do have a few that are showing up here for us, and the collaboration in the chat is great. Tony, your question: what are agencies doing to locate multifamily units, such as apartments with many building units and multiple individual units? Jenny and Sean both commenting on there that they get a copy of the building plans from planning and use them. They georeference those plans and they create a point for each. And Tony, you bring up a good point that you have tens of thousands of units in Dallas County. So of course that is a big task. With that, I know that at least offering what we have with our clients, we have an address comparison tool, as I believe John mentioned earlier. Our ACE tool helps provide a list of those and those address points that maybe aren't quite available to you in your current records. And with the ACE tool and the ACE process, we then offer a follow-up of that actual address placement. And looking at that, that's something that we offer. But with a lot of these workflows and kind of segueing into this workflow discussion, things are going to be very unique to your situation, your PSAP, and your scenario. And so there's going to be a lot of different approaches here. Let's see. Yes, Vicky, that's another great point. John helping us out there and contributing. So again, please continue this conversation and this collaboration and these questions. Keep them coming. I'm going to move on to our workflow. I'm actually going to just stop my video here just to preserve some of the quality. But with looking at this, our workflows, we want to create that purposeful order. So, of course, there's always efficiencies that you can find and efficiencies that work, especially when you're dealing with GIS data and spatial data. So it's something that's important to focus on, and something that John's talked about so far. And in our previous webinar, I know my colleague Annie Cahill talked about maybe who and those connections and those contacts. Something that I want to talk about is more towards the data-centric side of creating that purposeful order and looking at those efficiencies, and kind of highlighting something within the NENA standards of that 72-hour data turnaround. So it is kind of a scary thought at first to hear that we've got that quick of a turnaround when we have updates to our data. But if you have a good workflow in place that's identified those efficiencies and been able to implement them into a workflow, it goes from scary to we're prepared and our system is prepared. We are prepared. We understand how this is going to happen, operate step by step. So it's important to develop these and look at these scenarios for each one of your layers and spatial layers that you're going to be looking at for next-gen 911 with these NENA standards. For our folks here and our clients that we work with, we have our validation guide that comes in our knowledge base out of VEP. So with VEP, of course, you get that's validate, edit, and provision. You get those validations, the anomalies that John mentioned, where you're going to be able to assess your data at certain levels for each of those layers. For the validation guide, really what we've taken is look at our experiences with data remediation remediation and identifying what's going to be a little bit easier, what might solve some problems and offer some solutions before you even get to those problems. That's with our validation guide. So we of course, there's things broken down into our points, lines, and polygons, right, for GIS. So with that, you have your polygons, your boundaries. We recommend looking at those, identifying the problems there. And then your road center lines, of course, your lines, focusing on those in your next step, and then your address points. So finalizing those. And once you get everything together and you have that solid foundation for your data, of course, it is a cycle that you're going to consistently maintain. Once you have that established, you can then start doing those comparisons and those analytics. So we've mentioned the MSAG, we've mentioned the ALI, those different data sets that are maybe more in the legacy format, but still are in our requirements as a backup. If your data is solid, it's something that you can then be confident to compare against. So having that purposeful order in your workflow is extremely important, especially when we have these shorter windows. But of course, this is data that's not just any old data. Like we've said, this is people's lives at stake. This is extremely important. Saving one life is worth the effort. So with this, it may seem like a lot when you're going through this NENA documentation, and please share in the chat how familiar you are with some of this documentation, and if you're a veteran, if you're new, if you're looking into this stuff, you're kind of in the weeds now. What are your thoughts on the approach and how familiar you are with the documentation? What I'd like to break down for us is exactly what we're looking at. Again, I broke it down before with points, lines, and polygons. Here, I want to break it down into what we're actually seeing standardized. So we have our layers. I know that someone asked a question earlier, those layers specifically. You can find them in the data model in the NENA CLDXF documentation, both on the NENA site. But those break down exactly what layers are there, what are standardized, mainly focusing on public safety. And of course, our address points, our road center lines, our PSAP and emergency service boundaries are going to be our core NENA layers there. But for this, you have those layers. Those layers have fields that are maintaining your data with attributes. So breaking this down in sort of like a nested loop here. We've got these layers, fields, and attributes. All of those have standardizations that are broken out into this documentation. We also look at legacy synchronization. So looking at that 98% sync, looking at your MSAG and ALI and how synchronized that is incorporated into the spatial data set and the schema. So looking at legacy, whenever I discuss legacy fields, this is what I'm referring to. So what your legacy fields have off of NENA should be what is matching to your MSAG and ALI. Another big point that I'd like to make that isn't necessarily, I would say, emphasized outside of the standards or within the NENA standards, outside of like maybe your NENA global unique ID, is just having unique identifiers in general. So looking at it, saying that road center line 1, road center line 2, address point 5, address point 6, going through those, of course, you're going to have several. But having something that can attribute to a certain segment, a certain point, a certain polygon, being able to uniquely identify those features can be extremely important, not just in public safety approaches to GIS, but in GIS altogether. It's something that we not only encourage, but have as sort of a requirement in our process. But it's something that I really do encourage as you work through the beginning of this, if you are in the beginning, or even if you're in the thick of it, always including these unique identifiers allows you to identify problems just that much quicker. And of course, you want in this workflow design and in these discussions, you want to have a discussion on your level of maintenance. So there's The standards, which we'll see in a second, how they have requirements, whether they're required, conditional, or they're optional fields. There's a decision that has to be made on the levels of maintenance for each of these layers. So looking at some examples, there's things such as domains, which for those that are just dipping their toes in the GIS water, domains are a list of attributes that you can choose from when you're going throughout your fields. So instead of having to type in maybe Adam Street, I'm typing in or I'm selecting, from a list. I guess a better example would be in a parity in a road center line. So I'm selecting even, I'm selecting odd, one of those for a parity instead of writing that out. So instead of me getting an EVN or an E or an O, I've got something that's consistent. So domains allow for consistency, allow for a level of maintenance. There are some, standards that are with NENA on domains, but of course, it's always great to introduce these into your data to limit those input errors. Subaddressing, I know that we've already kind of talked about this a little bit, but subaddressing can be really, really a daunting task. It can be very heavy in lift and figuring out your approach to subaddressing. So the importance is, figuring out how you're going to obtain that data, the process for that, as some of our folks here have mentioned in the chat, in collaboration together, how they approach that. Of course, it's going to be your level of maintenance in that necessarily that discussion. With the levels of maintenance, you have NENA, which goes all the way down to the seat that's in the room, that's on the floor, that's in the building. There's all kinds of different approaches within the NENA standards to the level of detail that you'd like to have for your data. So not only figuring out how you're going to obtain that data and what you're going to do, but how you're going to maintain that and to what level you're going to maintain that. Another example here is elevation. So looking at your road center lines and deciding, from the naked eye, looking at GIS, when you have two lines that are over top of each other, it looks like they're intersecting, but that's not always the case in real life. Again, why we call them anomalies, and sometimes there's exceptions to that rule. With elevation, you're able to differentiate between that's actually an overpass. They don't intersect at all. There's no road intersection, and that separates that for you. So deciding, is elevation something that I'm going to maintain, how I'm going to maintain it, and that approach. So deciding your levels of maintenance for your data requirements, designing it not only around NENA, but what works best for you and your data. And so what I want to show here is part of the NENA data model, one of the tables here for the road center lines. So you can see here I've got highlighted some different colors, and there's a lot of information, but just to kind of pick this apart here with me in an approach of how I would assess this. So of course, like I mentioned earlier, the NENA globally unique ID, that's something that with this red coloration I have here is required. So you can see we've got broken down in these tables a descriptive name, our field name, so what's actually going to be represented in GIS, if it's required, the type of data, which is further defined in the documentation, what those mean, and then of course the field width. So how long is this going to be accepted? What length of data is going to be accepted? So of course, when you're looking at your roads, you want to have ranges defined, your left from, your left to, your right from, your right to, and of course you want to have that parity. So you can see that all of these are required fields. Your highs and lows are going to be your numbers, and your parity is going to be a text field, and then your field width there. So with parity, I can say E, O, even, odd, both. There's a couple different options, but all of that can be simplified into one letter, and so we have a one field width. So that is just kind of an example of how things are going to be universal. So what those standards are trying to achieve is having us all be on the same page with the approach. In the next panel, you can see that we've got some other options. So we've got a conditional field with the additional code left and right. So these are ones that you're going to want to maintain, or if you're maintaining that field, you're going to want to maintain that data. You're going to want to make sure that that is up to date and working correctly. And then you might have some optional fields like we see defined in the green down here with your road class, the one-ways, the speed limits. That's something that is, again, a level of detail and a level of maintenance that we're trying to approach. So it might seem simple to say, I don't know if we can do the speed limits. But if you look at the speed limits, even though they're optional, speed limits in one-ways might be something that can define that you have a better spatial call routing and a quickest route in a CAD. It's something that is a great thing to keep in mind. It's do I want to maintain that level of detail? Am I able to maintain that level of detail? Of course, we want to maintain as much detail as possible, but we have to also keep it both realistic in our workflow and advance our workflow when we're able to advance. And so some technology and tools that can help us in this journey and trying to get to meeting these next generation 911 standards. And if you have your own validations or you have your own tools, like what John was mentioning earlier, please feel free to let us know. What are you using? We're curious. Of course, we offer VEP as our software and the validations that come with VEP. So working with partners like us allows you to maybe have that software in those systems. You can see here a nice example of our dashboard that you would see, logging into VEP, getting some overview and knowledge of what your data looks like. But talking outside of that software, what's something that if you're maintaining a GIS, maybe you have an ESRI software loaded in and you're working that locally. What are some options for me here? So looking at that, scripting can be as advanced and as detailed as you want it to be. So you can go as simple as labeling your data, which we'll see an example of here in a second, doing field calculations to populate your data, or being super advanced and providing some automation in that process and looking at model builder. There's lots of different options here that scripting provides, and it's something that you can decide the level of detail that you go into. Of course, I've talked about a lot domains and attribute rules, domains allowing to or limiting that those input errors. We all accidentally press the wrong button or two. This allows you to sort of limit that in your approach to data maintenance. And then, of course, your field collection tools. I feel like these have really advanced in the last couple of years. I know a lot of the early part of my career with internships was a lot of field collection, but making sure that road sign matches what you have on that road center line, making sure that what your boots on the ground are seeing is representative in that data and that everything is matching up. Field collection tools can be extremely important and helpful in doing that verification.
And Adam, I
And
know
so
that
to
one of
kind of,
the
yeah,
sorry, I know that one
go
of the
for it.
challenging things that we run into here too is road name parsing, and that's one thing that we've scripted internally. So depending on how you maintain your road names, translating that into the NENA data model, you're going to have 8 road name fields in the NENA data model, and some of those fields are concatenated together in a single field in your legacy standards. And so being able to separate that out and do it intuitively, we've scripted a lot of stuff, and then even that scripting helps reduce the amount of work that we have to do manually. But we still even run into some situations where we have to go back and manually parse those tools. But I couldn't imagine trying to take a county data set and parse the road name out into 8 different fields without some form of scripting. I think that would be very challenging.
Yeah, scripting's a huge help and something that I always, at least for me, I've always had an interest in, as it always makes things a little bit easier on the day to day. One of the examples I have here on scripting, and I kind of, when I mentioned it, you might be thinking labels. That's just labeling my data that I'm visually seeing. How does that really help me in this process? Well, if we look at the left here, it's kind of a before and after, so to speak, to a left and a right. In the left here, you've just got the road name, you have it represented in symbology, and you have your address points that are labeled with the road name. But if you do some scripting just on the labeling side and sort of adjust that just a tiny bit, taking a couple of minutes, looking at it now, it brings to light a little bit more information for me when I'm trying to visually compare data. So now you can see I have directionals on my road. I know that it's not ending in the post type park, it's ending in the post type road. I'm able to see my ranges, my parity in the ranges, being able to see if it's even or odd. And then it's kind of hard to see. I should have kind of probably put this a little bit back more, but up here I actually have a arrow on the end of my road showing me my road directionality. So I can tell, is this flowing with my address points? Is this working? Is this going to make a match together with these address points and road center lines? And of course, with the address points, I can see they're even. I can see they're even on the even side. I can see they're advancing and flowing in the right direction. And I can see those directionals and, of course, the post type, and that everything is matching up. So this is just kind of a very simple thing that you can do in your day while you're working through this data remediation, just to bring things a little bit more to the surface and make things a little bit faster for you. Of course, we also have field calculation scripts. So looking at these pre-designed scripts that are from what we see here in this screenshot from ArcGIS Pro, something I just pulled this morning. You have a code block where I can have SQL or Python. I have all of these different options that I can myself, if I'm super, wanting to get advanced with this, jumping in and writing my code. We also have breaks in here that we can put in, so you can see our plus, our minus, our equals. We can mess with this as much as we want. And then we have our pre-designed. So one of my favorite ones, kind of connecting back to the unique ID we were seeing earlier, is the function. There's a sequential number. So creating a integer field and then just populating that with this calculation allows me to have a sequential number that's now unique. So having these different approaches really helps with your field standardization and your population. Another one that I want to show here is, you'll see this SW and Southwest. So standardization within NENA, we typically want to approach it in a mixed case, spelled out approach. So I take a script and I go from SW to Southwest with all the other directionals included in just that quick example. So just finding ways to not only automate, but make things a little bit easier in your approach to standardization is something that's extremely pivotal in doing data remediation. So that's going to wrap up what I have, at least on like the technical approach to things, and maybe what you're looking at on the technical side for approaching that. I do want to hand it back over to John for this next slide, just talking about remediation grant examples.
Sure, thanks, Adam.
And Anna, that's a wonderful point, bringing that up. Sorry to cut you off, John. Just looking at that in the chat. More scripting with Arcade. There's a free one right there, free course from Esri. So it's stuff that you guys can use to improve your sort of almost quality of life improvements with working in these softwares and everything.
And I think I'll actually go take that. I've come up through the ranks with started out in Avenue and VB and Python, and I don't know anything about Arcade, so I think that'd be a good one for me to see as well. Thanks for bringing that up. All right, just wanted to give you a couple of examples of different grants that are out there. So, there is funding out there to help with data remediation, and this is just two examples of different states here. So the first one is the state of Missouri, and it's really hard to see on the screen here just due to the resolution. At least it is on my side. But if you look down at the very bottom, it's GIS Remediation Grant Materials. That's actually the link that you click on for the state of Missouri. I know very little about that grant. We do have a guy that lives there in Missouri, though. So if any of you folks are from Missouri and you want to learn more information about the grant, my counterpart, Rich Ryman, lives there in Missouri, and just reach out to me. I'll put you in contact with him, and he can tell you all about that grant. I do know that grant is open to 2025, and I don't know the ins and outs of that grant specifically. I do know a little bit more about the State 911 grant for the state of Florida. So this is a grant that cycles twice a year. So every county within the state, all 67 counties, have the ability to apply for this grant, and it funds a majority of the capital improvements that go on at the PSAP level. And so it takes care of everything from GIS to call handling equipment. I think even furniture is involved. So anything within the four walls of the PSAP that that's directly related to call delivery. So I think GIS ranks, they are priority 2 in that grant, and we're working with several different regions there in Florida. So we've done a 12 county region, which is region 1. We've completed a 15 county region, which is region 3. We're currently working on region 4, which is 9 counties, and then region 5, which is another 9 counties. All of those were completely funded, 100% funded through the state grant program. It's not only funded the GIS data remediation portion of it, but also the software, the tools, the technology for maintaining that data. So they're calling them GIS data repositories in the state of Florida. And the state of Florida has taken a regional approach. That's why you see all these regional repositories. At some point, they'll aggregate the regional repositories into a statewide repository. But those, that grant funds it for 5 years as well. So there's other examples in other states. I know Tennessee provides some money. If just about every state has some form of grant funding to help with GIS projects. Some a little bit more than others. It depends on where they're at in that progression towards next generation 911 oftentimes. But those are 2 great examples. And if you need more information on either one of those, like I say, just reach out to me. If I don't know the answer, I'll put you in contact with the person who does. So just know there is funding out there available. It takes a little bit of research. Sometimes it takes a little bit of work to get the grant funds. That's where we step in. We can't fill out the entire grant application for you. There's certain things that we're not privy to, and probably just shouldn't meddle in that. But we can help with some of the research. We can help with some of the justification, the schedule, stuff like that. So we can take some of that administrative burden off of you guys if you just reach out to us.
So we do have a slide here for questions as well as upcoming webinar topics, and I know that we were aiming for about an hour, and you're welcome, Tony, and thank you for you guys providing your time today and collaborating together, asking these great questions. We really do appreciate it, and it's great to work with you guys and hear where you guys are at currently in your journey. If we want to discuss any of these upcoming webinar topics, or if you guys have any questions, of course, post today's webinar, please do reach out to us. We do have our contact information here as well, both John and myself. So thank you again for your time. And with that, Stephanie, I'll hand it back over to you if you'd like to close us out. But sincere thank you from me and John for your time today, everybody.
Absolutely. Thanks everyone for joining us. I will put a plug in for next month's webinar. If we're doing it on indoor mapping, a case study, and just as a GIS nerd, you'll want to see this. There's some really cool stuff in our indoor mapping. You want to take part of that presentation. The addressing one's good as well, and the standards is also good as well. But if you want to see some really cool indoor mapping technology, just join us next month on our webinar there. Please do. Thank you all. We appreciate you. And Ian, I'm sending you Rich's email just in case you want to get in contact with him. And if you'd like, I'll set up introductions for you.
All right, awesome. Well, thanks so much, everyone. Thank you, John and Adam, for putting on a great webinar today. As always, all of our information can also be found at datamarkgis.com. So if you didn't get a chance to register for these webinars you see here, you can always do it on our website. We also have quite a bit of information on sub-addressing and normal addressing, which is always a hot topic. So datamarkgis.com. Thanks, everyone. Have a great Tuesday.